Hello, check. You guys can hear me, right? Perfect. So, yeah, welcome. So, today I'm going to talk about more into the field of security and especially in containerized environments. The previous talk that you just saw about Kubernetes deployments, Kubernetes environments, and so on, you can consider this as a continuation to that because we are going to see about what exactly is the security aspect to containerized application running on Docker, running on your local machine, running on a shipping environment like Kubernetes, whatever it might be. There are some things that we should be considered about, and these are things that are good to know. We'll go back to the basics, and then we'll move forward from there. Yeah, so container security for enterprises, my cat remains with me in every session that I go to. So that's Pablo. Yeah, so you can find me on Twitter, 1MR0. So I'm a cybersecurity and DevOps engineer. More about me, I have my roots in the field of research. I consider myself as a researcher in the field of cybersecurity, also in the field of MLOps. As well as I'm a certified ethical hacker. I work in the field of DevSecOps, trying to build secure environments, cloud security, application security, web application penetration testing, vulnerability analysis, whatever you put under the umbrella. Also, I look after the ease of deployment because I myself, as the last point, I'm lazy. So I tend to build systems or I tend to build security where you don't have to put your brain into as far as possible. It's me who does the work, you stay lazy. So my definition of. My definition of is an aspect that I put in every single presentation of mine where we go back to the basics and then we understand from the bottoms up. And we build a base actually. So what is the thing that we are going to build? We are going to build a base on container security. So container security has been something that has been in the field for quite some time, but has gained the popularity with the popularity of containers at the end of the day. So it has increased dramatically. Although container technologies have been around for years till now, with the introduction to Docker and such environments where you can containerize your application, it has come more into play. So there are tiers to this. So if you go into the field of virtual machines, right? So as well as in the field of containers, at the end of the day, there is a base image. The base image has its security vulnerabilities. The base image has its flaws, maybe, if you're not versioning it properly. If there is no patch management, the base image contains some vulnerabilities. If you are deploying an application which is built on some, say, an older version of a Node image, or older version of a Python image as the base image, that contains your own security vulnerabilities. If you are going into logs, your container logging, you use a command like kubectl logs -f and then put the container ID, and you see syscalls or you see logs that say that this is my SQL server that it is connecting to in a microservice-based environment. That's a security flaw that you have. So each and every level, starting from base to operating system, to the kernel, to the application that you are building, everything contains layers. The DIY kit for devs. We all know this guy, right? Who is this? Rob from MAD, right? Or if you're not familiar, you belong from the UK, you have watched a show called Art Attack with Neil Bachanan, right? So what did these guys actually had kids in their shows, right? Palak was one of the kids that Rob had on his show. What did the kids get at the end of completing a successful project or successful art? They got a kit, right? This is a kit that you can use to make fridge magnets. This is a kit that you can use to make posters. So that kit contains things like, say for example, a fridge magnet kit. I personally got that kit, right? So that contained plaster of Paris to build your magnets. That contained magnets to attach to the end of your fridge magnet. That contained molds, everything. So That's a brief example of what I'm trying to give when it comes to containerized environments. I'm giving you the operating system, I'm giving you the kernel, I'm giving you the dependencies that you have, and I am giving you the application base that you need in order to deploy your application. Whether it's a microservice environment, whether running as a single cluster, whatever it might be. Yeah. So with great power comes great security challenges. So each and every level has a single security vulnerability that we need to address. Not exactly a vulnerability, but a security aspect that we need to address. Whether it may lead to something like cost reduction, whether it may lead to system services, functionalities, the efficiency, or the overall aspect of your application running in that particular dev stage, production, pre-production environment, right? So the slides are pretty much self-explanatory. I won't go into the details of that, but the interaction between the container, the host operating system, and the other containers on this particular host in the form of logs or in the form of syscalls. So the host operating system contains its own vulnerability. We'll see how host operating systems affect your vulnerability score at the end of this demo, if the demo works properly, if the internet is working properly. Let's start from storage. So storage of, I'm not talking about the database storage, or I'm not talking about the storage of data for your application, your SQL, your Postgres, your MongoDB, your Redis, whatever it might be. I'm not talking about that. What I'm talking about is your storage of containers. Whether you be storing it in Docker Hub, whether you'd be storing it in Google Container Registry. These two are the ones that I am familiar with. If there is any other, feel free to suggest. So if you are putting it in, I'll give you a scenario. So say your application is running on Kubernetes. How many of you have seen a UI application or any application running on Kubernetes? Run. Cool. So are you familiar with the SVC URL? /SVC, /namespace, /cluster, so on, right? So this is something, yeah. You have a question? Oh, you have seen, okay. Fine. Feel free to mock me if you have any questions. I'm open to that. Yeah. So that URL, say it's exposed on the internet, right? So from that URL, you get your, and it's stored on GCR, the Google Container Registry. You get your namespace, you get your project ID, you get your application name, any microservice name that you might have from that SVC URL. Try to brute force into GCR. If the GCR is public, you get the image, right? You get the image, you pull the image, you run it on your local systems, you get into the logs, and you see some logs that say that your container that you are running is connecting to a MySQL service using so-and-so IP. Brute force into MySQL, you are in. How do I know this? Because I've done that. So yeah, hosted Docker registry. So the Docker trusted registries are there. Best practices, obviously, private GCR, private Docker Hub. However, you might try to, if it is like in an Anthos environment, if it is an on-premise environment, you have your own dependencies and your own features to be implemented there for improving the security. Containers contain. This is syscalls. So syscalls, so it contains of three parts. Firstly, the obvious that we all know about, one is the Linux kernel space. The Linux kernel that is running, if there is a process, there's a RAM, there's a disk that is associated with this particular container for exactly. And there are syscalls. Syscalls are basically these interactive calls. You see it in the diagram right there. The process that is on the user space and the kernel space that contains the RAM and the disk are communicating via syscalls. What are these syscalls? How do we view syscalls? We are going to see in the demo, right? Okay. So these syscalls, you can have syscalls like create process, end process, read file, create file. You can see. So say, for example, I get a syscall that says read file, right? You get the particular file path that you are trying to get. If it is a credentials file, then boom, you are in to go. How do I know? Because I've done that. So this is a very famous tweet by Jerome Patazzoni. I hope I'm not slaughtering his name. Containers are processes born from tarballs, anchored to namespaces controlled by C groups, right? So everyone is familiar about namespaces in case of Kubernetes environments, right? Namespaces basically give you the illusion that you are living in a isolated environment, right? So, and C groups are your particular groups or the particular permissions that I am giving to this particular environment that I'm running. So these are the three parts that a container contains that we are considerate about, that we as cybersecurity architects or cloud security architects or working on container security are worried about these three parts. Obviously, there are other aspects to that. There's your application running. There are a lot of, other calls that you might implement into your system. There might be a, what do you call it, a sidecar that is running, right? Syscall monitoring with Falco. So I will be, in this talk, my main idea was, to implement container security and cloud security by means of some open source tools. Why open source? Any idea why open source? Because I'm broke. Yeah. So come on, I'm a recent pass out as well, so everyone is broke right now, right? So Falco. Falco is a tool that is in the news right now because it's being funded by right now. If you listen to the Kubernetes vlogs or the Kubernetes podcasts, then you might be knowing about it. So Falco is a runtime security project to join the CNCF. So it's got an incubation, right? So Falco acts as a security camera detecting unexpected behavior, intrusions, and data theft in real time, right? So I don't exactly have a setup that would trigger Falco as per se, but what I do have is an environment that I can show you in order to set up Falco. Now, there's a hack that I built in this case, and that hack is that I wrote the commands from before, so that I don't waste your time, I don't waste my time. We'll just wait for this to reconnect. Wow, that was fast. Cool. I hope the text is visible to everyone. Yeah? Cool. So Falco can be installed with Helm as well. So if I see on the next slide. So if you want to follow along, you can type this URL down in your mobile phones as well. If you want to just look at the commands, it's nothing as of such that you have to run right now. But if you want the commands that you will be using in order to install some tools, in order to run some tools, this is the URL that you can follow. Also, this URL is going to be in one of my Medium blogs that will be coming after this. So you can follow up there as well. It's as easy as a curl -o install Falco, installing the downloading the install script, checking the SHA-256 sum, and then sudo bash install, right? So we'll be using that. Okay, so a little bit about the VM that I'm using here. So this VM is known as something called a bastion host. Anyone familiar with the term bastion host? Yeah, please. Can we give him a mic, please? Oh, who asked for the mic? It was him. Okay, you wanted to answer, right? Yeah, take the mic.
Yeah, like in a private, if it is in a private subnet and you want to access that, you will put it on a public subnet, and that is called the bastion host. Something in the middle.
Fair enough, fair enough. So bastion host is something that we call dalal in Hindi. Okay. So it's basically a middleman that sits behind your, so if you are doing it on a Kubernetes cluster, right? So you are not going to go into the Google Cloud command and then type in the command shell, kubectl, and then get the entire thing, right? Rather than what I did right here is you create a VM that's called a Bastion host. You install gcloud inside of that and run the particular Kubernetes cluster connection command or the connection string to that, right? So it always stays connected. You instead of logging into Kubernetes using the Cloud Shell, you log into the Bastion host using SSH, and you have a simpler access to that. Now, if I require some extra tools such as Falco, such as Trivy, such as so many of the other tools that I'm trying to install, ThreatMapper, there can be some SIEM or SOAR tools that you are trying to install. You can try and install it on the Bastion host so that it gets a direct connectivity to your Kubernetes cluster, right? So that's a security practice that we do. That's a efficiency practice that we do as well, right? So let's see. Let's find the Falco commands, and we'll run that. Let's wait for it to complete. Now, why I have why I'm telling that Falco as per se will not work in this case is because I don't have a particular environment that's gonna trigger Falco. Okay, you need to trigger Falco in order for it to give you the security updates that you are looking for, right? Instead, what we'll do is we'll just see how Falco works. We'll just see what Falco shows us when we are running Falco, and we are going to see a tool called KubeHunter. So that's not part of my slides, but note these two names down. One is KubeHunter and one is KubeBench, right? For Kubernetes environments, these are becoming two of the most booming tools right now, right? So we're going to see how it works. Okay, so that is complete. Now if I type in Falco, what I'll do is I'll clear this out first. Right? So what is it doing? It's running a port 8765 as an internal server, right? So if there is any triggering events, if you want to see what are the triggering events or what are the rules that would trigger this particular event in Falco, you can see this particular file. So yeah, there's a trigger right there. User management binary command run outside of container. What does this mean? I don't know. So Google, just need to Google search this out, right? So it is triggered by a command. Now, if you want to, set the rules yourself, you want to disallow some of the ports, or you want to get your hands on this particular file, all you need to do is edit that particular file using Nano, using Vim, whatever might suit your fancy, right? Right? So we have these files right here that mention all of the rules that you have. So this is a rule file that you have. There's a audit, there's a cloud trail rule that you have, and so on and so forth. Watch config files, set it to true, set it to false if you don't want to. Include output property as a JSON. Set it to true if you want to, set it to false if you don't. Ends up to you, right? So you get the point of Falco, right? Is there anything that I can answer right now before we move on to KubeHunter? Anything? KubeHunter. Even more simpler than Falco to install. What I'll do first is I'll create an entry for my GKE right here. Just give me a sec. So this is a auto-scale enabled autopilot cluster that I have on my GKE. and I'm going to authorize it from my Bastion host. So it has, let's see if it has some pods running. I guess there are none. Okay, so let's run some pods. So let's just be to Nginx. Okay, so we have Nginx running. Let's do a kubectl get pods. We have Nginx pending at the moment. It will create in some time because it's an auto-scale cluster. It will scale first and then deploy. So while that happens, we are going to install kubehunter. So kubehunter is triggered by a, that's not the thing that I want. Yeah. So kubehunter is triggered by this particular file that is there available on their GitHub repository. Okay, all you need to do is get the jobs.yaml and install that. And let's see if we have the pods ready. Okay, it's pending. Let's wait for it to shoot up, right? Till then, I think we can see some logs. kubectl logs -f. The pod name. Nothing as of now. Okay, so while that's spin up, we'll go on to the further of our slides. So we saw Falco, we saw kubehunter. So we completed the last part of what we discussed as of now, the syscalls, the operating system concepts, and so on, right? Next, very nice quote by Mr. Drake, started from the bottom, now we're here. So what lays at the bottom is the base image, right? So most containers have a base image that is not versioned properly. If there is a new base image that is there, it's not there as of now in the particular production deployment that is there. So I have faced this issue, is that a Java developer calls me up and says that the particular scan that I'm trying to do, a Trivy scan or something like that, is showing me a Python vulnerability when I'm not using Python, right? That is because your base image contains a Python that is vulnerable to this particular, maybe a CV that is there, right? So with base images, please be, whenever you are using it as well, please be very careful on versioning it properly, because there are vulnerability patches going on every single day, right? So for base image vulnerability scanning, we are using Trivy. Trivy scans the container image that you are running. It scans the file system that you are trying to deploy. The Git repository remote, if might be there. There's the Kubernetes cluster that it can scan as well. So we'll see if our particular thing has spun up. Let's see. Okay, kubehunter is completed. So let's see if we can look at some logs from kubehunter. Right? So what do we see right here? We have exposed pods. We have local to pod connections, maybe a syscall, may not be a syscall, might be a false positive, might not be a false positive, right? So that is what we need to be a little bit careful about. So, and it gives you the IP address, it gives you the kind, it gives you the CVE if there is any, and you get the point. Right. Keynote. Yeah. So Trivy. Let's install Trivy. Trivy as well, you'll find the installation script on my blog posts, as well as you'll get it in this next slide itself. So let's run that. Okay, issues, okay. Now it works, all right. And then all you need to do is install this particular Trivy image. So since we have a time crunch, we're just going to wait for Trivy to install, and we are going to swiftly run through the next slides that we have. Right? So the next part that comes to this particular session is monitoring. Right? The essence of a security professional, the essence of you being secure in the first place, and that is monitoring. So I'm using New Relic for this particular example that you might put. If we would have the time, we would have done the demo. If that is not possible right now, but it will be on my blog if you want to follow it later, right? So we are using New Relic. There are other tools. Why is the thing that I didn't choose one of the most important and one of the most renowned tools named Grafana is because I would have to go through the concepts of PromQL and then log ingestion agents like Loki, log ingestion agents like Wazoo. So I didn't want to go into that. Rather than I came with a simple solution, I came with a free solution that is New Relic. So you can install New Relic on literally any system that you have. I have a system that runs New Relic and is functioning on New Relic. So yeah, I think Trivy's crashed down. Okay. Okay, while that logs in. Cool, so this is a Ubuntu machine that is running New Relic on its system. There are other data sources that you can add to this particular software, where no matter what your code base is on, no matter what your environment is on, Kubernetes logs, your Docker images, you can install it anywhere. And what you can do is, you can go to your, this is an instance, this is just one file or your one VM that is running. You can see the network traffic, the lead average, your process is running, there's Docker, there's container, there's gunicorn, there's deep fence. So these are some things that you can do using New Relic. Especially, you can do application performance monitoring, or what we call APMs, if you are running a microservice-based environment. The best part, it's too easy. Right. So let's go to the, sorry. Yeah. So security. Security is the final thing that we are trying to explain right here. So this is a, if you are familiar with something called a meter attack framework. So this is a meter attack framework for Kubernetes-based environments or container-based environments, right? So this is available on the internet. Just search for Kubernetes-based meter attack frameworks, and you'll get this particular, chart right here. So what are the things that we are trying to face? We are trying to face using cloud credentials, using default credentials, using exposed dashboards, exposed ports that we have, using INGs, instead of using INGs or ingresses, we are using an exposed port on a load balancer on GCP that is running on Kubernetes, right? So these are some things that we should be aware about, and it's all listed in this particular framework. And relating to this particular framework it comes defense, right? ThreatMapper. So while the containers offer some of the most amazing securities, Kubernetes, there might be some, we are the culprits right here, right? You might have heard some people say, it's not you, it's me, right? If you heard that line, you're like me, right? So if the human misconfiguration or our misconfiguration, the application misconfiguration, if anything is there, this will come into play. Whether it be GDPR, whether it be HIPAA, whether it be Payment Card Industry Data Security Standard, PCI DSS, everything is contained within this free tool called ThreatMapper. ThreatMapper dashboards are available on the internet. You can just install it using Helm 3, and you are good to go. Just 3 commands, and you are monitoring your Kubernetes clusters in just one dashboard, right? So don't let hackers give you a tough time. Right, so I think that was it. Rami Malik, this is not from Mr. Robot though, but I'm a big fan of Mr. Robot. Okay, any questions? All right, so thank you so much. Yeah, sure.
Good afternoon, sir. My name is Taza Alam. I had a few questions. First is, why are we running, can we run this Kali machine that you're using? Or whatever
it's an Ubuntu machine. We are not using Kali.
Or Kali, whatever you're using. Why not use it in a VMware rather than using it?
I am actually using a VMware, not exactly a VMware, I'm using a Google Compute Engine.
Why? Because if we are using it in a cloud-based machine, it might miss out on some dependencies. Whereas when we install it in local machines such as VMware or VirtualBox or anything else, they give you the full image.
Yeah, you can do that for the sake of ease, for my sake of ease, because I am broke, okay? So I don't have a machine that can support that right now, okay? So I am using a GC. If you want, you can use VMware. You can use VirtualBox to deploy your Kali Linux machine, your Ubuntu machine, whatever it might be, and you can integrate it with all of the tools that I showed you right here.
Okay.
As simple
Thank you,
as that.
sir. And one more question is that you said MITRE attack on Kubernetes. Why not use a different framework such as CyberKillchain?
You can, no issues. It's all compatible. Just to, it's an industry standard. MITRE attacks or MITRE attack tactics is an industry standard. So that is why I followed that. If you want to follow some other frameworks, if you want to follow some other compliance guidelines, you're all free to do that.
Thank you, sir.
It was just my preference.
Thank you, sir.
All right. Yeah, so can I get my slide back on? I just want to share my social links. Yeah, this is important. Follow me on Twitter. I have very less followers. Follow me on LinkedIn. I have very less followers. Follow me on Medium. I have very less followers. Thank you so much.